All right, we're going to get some practice solving rational equations. But before we do that, I want to talk about what a rational equation is and what it looks like. So a rational equation is just an equation that contains one or more rational expressions. And I've given some examples here. Often you'll have a variable in the denominator, maybe some things to factor. And so when you have a rational expression set equal to a rational expression, the strategy for how to solve that for a variable is a little bit different than if you're just simplifying an expression. Okay, so when we're solving a rational equation, the first thing we want to do is determine the LCD of all the rational expressions in the equation. So look at all the denominators, determine what the LCD is, and regardless of what side of the equal sign the expression occurs. Once you've found that LCD, the LCD includes all the factors that are present in all of the denominators, right? So if you look at the LCD, you can determine any domain restrictions on this thing, right? So make sure that you make note of those, and then multiply both sides of the equation by the LCD, and that'll have the effect of clearing the fraction, and then you'll end up with an equation, such as a linear or a quadratic equation, that you can solve. All right, then once you've solved it, go back and check your solutions. So stick them back into the original problem, see if they work. This is critical, particularly with rational equations, because you may get some solutions that don't actually work, even though you haven't done anything algebraically incorrect. And usually when that happens, it's because your solution disobeys one of the domain restrictions originally. So making note of those domain restrictions is important as well. In fact, that's one way that you can check it, to just check it against the domain restrictions that you found earlier in the problem. And then, of course, state the solution set. Okay, so here are a couple of examples we'll start with, and our goal is to solve these. All right, so the first example I have is 12 over t equal to negative 3. Okay, so if I'm thinking about what is the LCD of that, well, it's just t, right? That's the only denominator I have. So if I multiply both sides by t, okay, t will cancel over here and we'll be left with 12 equal to negative 3t. And I still have to divide, I still have to solve for t. So I'm going to divide both sides by negative 3. So I have that negative 4 is equal to t. Now, if I were going to check that, oh, sorry, right up in the get-go, I forgot to say t can't be 0, right, in the original equation. So if I'm going to check this, the solution of negative 4, 12 divided by negative 4, is that equal to negative 3? Yes, it is. Okay, so all I'm doing there is I'm inputting the solution that I got, a t equal negative 4, into the original equation for t. Does that work? Yes, it does. Okay, so the solution set is just negative 4, right, in those set brackets. Okay, so in the second example, I want to multiply both sides by the LCD. Okay, so in this case, what is the LCD? Let's make note of that. It was obvious in the first one, right? It was just t. Over here, it's 5 times 2x plus 3, right? All of those denominators are fully factored, right? And they don't have anything to do with one another, right? So we just have to take the product of the two to have the LCD. Okay, now also just a domain restriction, the 2x plus 3, if that's 0, what would x have to be? 2x would be negative 3, and x would be negative 3 halves. So I'd want to say that x can't be negative 3 halves. We get that as a solution, that's trouble. Okay, so now I'm going to multiply both sides by the LCD of 5 times 2x plus 3. All right, and look what cancels here. So the 5's will cancel on the right-hand side, and on the left-hand side, the 2x plus 3. All right, so on the left-hand side, I'll be left with 5 times x minus 1. And on the right, I'll have 2 times 2x plus 3. All right, and now I have an equation that I can solve. So I'm going to distribute the 5 through, so I'll have 5x minus 5 equal to, distribute the 2 through on the right-hand side, so I'll have 4x. 2 times 3 is 6, 4x plus 6. Now I'm going to subtract 4x from both sides. So I have 5x minus 4x minus 5 equal to 4x minus 4x plus 6. So I have x minus 5 on the left equal to 6. And then I want to add 5 to both sides. So I have x minus 5 plus 5 equal to 6 plus 5. So x equal to 11. Okay, and I want to check this. Check it. If I stick 11 in for x, 11 minus 1 over 2 times 11 plus 3, is that equal to 2/5? Question mark there. Okay, so you have 10 over 22 and 3 is 25. 10 over 25, 5 goes into each of those, right? Okay, so 5 goes into each of those. It goes into 10 twice and into 25 5 times. So 2/5 is equal to 2/5. Yes, that works. Okay, so the solution set is 11. Okay. All right, now just an aside here. I just want to talk about something real quick. In this original problem, x minus 1 over 2x plus 3 equal to 2/5. Because you have a single fraction equal to a single fraction, you can do what's called cross-multiplying here. So you can multiply 5 times x minus 1, for instance, equal to the other cross, right? And 2 times 2x plus 3. You'll notice that when we multiplied both sides by the LCD, that happened anyway, right? So multiplying by the LCD works every single time, no matter the situation you have. This cross-multiplying trick only works if you have a single fraction equal to a single fraction. And there are some cases in which it actually doesn't pay to cross-multiply. It's easier if you multiply both sides by the LCD and cancel that out. So I recommend sticking with the original plan. So if you had some math before, you might have learned the cross-multiplication technique. And it's an okay way to do it. Just be careful with it because it doesn't work in every scenario, and sometimes it can make your life uh, not easier. Just keep that in mind. I would stick to the multiplying both sides by the LCD. All right, now let's do a couple more examples. So in this example, we have 1 over 2x plus 1 over 3x is equal to 2, and we're asked to solve that for x. Okay, so the first question I would have is, what is the LCD? So of all those little denominators there, the LCD, well, between 2 and 3, that would be 6, right? So 6x would be the LCD, right? X is present in both of those denominators. So I'm going to multiply both sides by the LCD of 6x. Now, I'm going to write out an additional step here than I need to, just to show you what's happening. You have to distribute the 6x to both of those terms on the left. So you're really going to have 6x over 2x plus 6x over 3x equal to 12x. Okay, now in this first fraction on the left, 6x over 2x is really just 3, right? And 6x over 3x is really just 2, equal to 12x, right? Okay, so this step right here that I just did, you don't need to do it if you can see what's happening, right? So if you can tell yourself, well, 6x over 2x is just 3, 6x over 3x is just 2, kind of use your fingers and think about what is that going to reduce to. Sometimes writing out that step is more helpful, and sometimes you can get lost in it. So just keep that in mind, and certainly it's a step that you should write if you need. Also, remember, when you're done with that step, multiplying both sides by the LCD, you shouldn't have any fractions left, right? So what did we end up with here? We ended up with 5 equal to 12x. It's a linear equation, right? And then to solve for x, I have to divide both sides by 12. And so I have 5/12 equal to x. And as usual, I forgot to state the domain restriction, right? X can't be 0, right? If I look in the original equation, that's the only thing that will make the denominator 0. So if, as long as your final solution doesn't disobey any of the domain restrictions in the original equation, you're probably fine with it. Okay, this one is more challenging to check because there's a fraction involved, but let's give it a try. Let's just give it a try checking here. So if we have 1 over 2 times 5/12 plus 1 over 3 times 5/12, is that equal to 2, right? So I'm going to simplify this. 2 over 12 is 1/6, right? So we're going to have 1 over 5/6 plus 1 over 3 over 12 is 1/4. So I'm going to have 1 over 5/4. Is that equal to 2 here? We don't know. So multiplied by the reciprocal of the denominator, right? The reciprocal of the denominator is 5/6 and the numerator is 1. So we're going to have 6/5 plus 4/5, right? Multiplying by the reciprocal of the denominator. 6 and 4 is 10, right? So I have 10/5 equal to 2. Is that true? Sure is, yeah. Sometimes checking it can be a really good fraction work practice, right? Yeah. All right. So let's do one more here. Okay. So with this example of r plus 6 over r squared minus 36 equal to 0. Okay, now some of you may look at that and say, well, even without factoring the denominator, if I just multiplied both sides by r squared minus 36, because the right-hand side is 0, then that would just give me r plus 6 equals 0, right? So, and truthfully, if you have a fraction and that's set equal to 0, in order for that to be true, the numerator has to be 0, right? So ultimately, that's what we're going to be doing. We're going to be setting the numerator equal to 0 and solving. But I want to just poke at this a little bit more, because what happens when we factor that denominator? So we've got r plus 6 divided by r plus 6 times r minus 6, right? Because that's a difference of squares, r squared minus 36. Okay, so first of all, what is the LCD of this? The LCD is r plus 6 times r minus 6, right? Okay, and based off of that, that's what makes the denominator 0. We know that this has a domain restriction. R can't be plus or minus 6. If we get either one of those as a solution, then it can't be, right? Let's, instead of canceling out the r plus 6, let's just multiply both sides of this by the LCD. So I'm going to multiply the left-hand side by r plus 6 times r minus 6, and the right-hand side by r plus 6 times r minus 6. Okay, now over on the left-hand side, the whole denominator gets canceled out and we end up with r plus 6. And on the right-hand side, 0 times anything is still 0, right? Okay, so we have r plus 6 is equal to 0. Subtract 6 from both sides. R plus 6 minus 6 equal to 0 minus 6. So r is equal to negative 6. But we said that r can't be negative 6, right? So if it can't be negative 6, then what do we say about this? Well, we say that there's no solution. Yeah? Okay, another little aside about this. Let's say we had canceled that out, right? We had the r plus 6 over r plus 6 times r minus 6 equal to 0. Okay. If we canceled that out, we would have ended up with 1 over r minus 6 equal to 0. I would have multiplied both sides by r minus 6 to get rid of the fraction, right? Okay. There they go. We ended up with 1 equal to 0. Is that true? No. If you solve any equation and you get the variables to fall out of the equation entirely and you get a false statement, there's no solution. So what's the solution set? It's the empty set. There's nothing in it. Think about some of those things. And that can happen to you too with a rational equation. You can actually have an equation that doesn't have a solution. You can have an equation where you solve it and think there's a solution and then it disobeys a domain restriction, as in the case here. And careful canceling out terms before you multiply both sides by the LCD because you can miss solutions too. So anyway, an interesting problem.